Good morning, all of you. Welcome to Sri Jayendra Ink Zone. So far, we have completed all the chapters, all the topics in the chemical bonding lecture. Now, we are going to discuss questions based on the lecture of chemical bonding, which is very, very important. So, total entire concepts, questions I am discussing right now, you can able to listen carefully. So, all these questions are very, very important for discussion. So, that's why I kept. And if you notice, all these questions are nothing but previous competitive exam questions, that is mains as well as advanced as well as neat. So this chapter is very, very important definitely for each and every entrance exam, since this is a very big chapter. For each and every exam, definitely you are going to get 4 to 5 questions. So that's why now we are going to discuss problems on chemical bonding. So let us see problems on chemical bonding. Yes, right now we'll start now. So far we have completed all the topics in total 6 lectures. We have completed all the topics in chemical bonding. So now let us see question number 1. Question number 1. The octet rule is not valid for which of the following molecules? So according to octet rule, what is octet rule? Before going to answer, let us discuss what is octet rule. So according to octet rule, after sharing, the element should contain at least 8 electrons in the valence shell. So if an element and if an atom in a molecule contains 8 electrons in a valence shell, we'll say it is nothing but following octet rule and it is stable. So example, carbon dioxide, if we take into consideration, water, oxygen, nitric oxide. So in all these molecules, if you see here, in all these example, they are given carbon dioxide, water, oxygen, and nitric oxide. So octet rule means after sharing, they should get at least 8 electrons in the valence shell. But if they get less than 8 electrons, we'll call it as electron deficient. More than 8 electrons, we'll call it as electron rich. And equal to 8 electrons, we'll call it as electron sufficient. So electron deficient, electron rich, and electron sufficient. So we have 3 types of molecules. So let us see carbon dioxide. So in carbon dioxide, what happens? CO2. Carbon is having 4 electrons in the valence shell. Okay. So these 4 electrons are shared by 2 oxygens. Each oxygen can share 2 electrons. So after sharing carbon dioxide, alone carbon gets 8 electrons. So it is following. So it is getting 8 electrons. Like that, you have to see for each and every compound in the given. So first carbon dioxide is not following, is following octet rule. Next water also, if you see, oxygen contains how many electrons in the valence shell? 6 electrons. 1, 2, 3, 4, 5, 6 electrons. And 2 with hydrogen it will share. Just an example I'm giving. These are not the exact diagrams. So total after sharing with hydrogen, it has total again 8 electrons because it is also containing 8 electrons. So it is not all, it is also following octet rule. Next, oxygen molecule following octet rule, that also you can see here. So oxygen, each oxygen, O double bond O. So here 6 electrons, here 6 electrons. Commonly it is sharing 2 electrons because of double bond. So we can say it is also having 8 electrons because each oxygen is having 6 electrons, out of which 4 will be for this and 2 is sharing, it is common with this, and this is also sharing 2 electrons. So on the whole total 4 electrons in the middle and outside is 4. So this is also following. Let us see. So since all the 3 is can, so answer is NO. So let us see NO, nitric oxide. In nitrogen oxide, nitrogen is having how many valence electrons? 5 valence electrons, and oxygen will share only 2 electrons. So after this, what happens? Total after sharing with nitrogen, it is getting only 7 electrons. Means it is nothing but not valid for octet rule. So answer is nitric oxide. I hope it is clear. So nitrous oxide is the answer for this question. So answer is NO because it is not. It contains after sharing. I'm writing here. After sharing, it is giving only. Is getting only 7 electrons, which is less than, which is against octet rule. I hope it is clear. So please note down. So this is question number 1. So question number 1 we are discussed. In this lecture, we are discussing entire chapter questions. Now, the compound which contains both ionic and covalent bonds is very, very important here. Both ionic bond and covalent bond. So, ionic bond means what? Transfer of electrons from one atom to another atom. And covalent bond is sharing of electrons. And CH4, first if you see the first option CH4, It's completely covalent because carbon is metal, sorry, non-metal, and hydrogen is also non-metal. And hydrogen molecule also, it is purely covalent bond. Potassium cyanide, if you see, this is ionic bond, we can say, because potassium is metal, cyanide is a radical which is non-metal. And here potassium chloride also. Potassium is metal, chlorine is a non-metal. So potassium chlorine is purely ionic. And potassium cyanide, if you take into consideration, let us see the example of potassium cyanide. So in potassium cyanide, what happens? Potassium K, just writing it again. Potassium K, C, triple bond N, because cyanide forms KC triple bond N. So C triple bond N. Formation of cyanide ion is because carbon and nitrogen together they combine to form cyanide. So cyanide ion and potassium K plus. So cyanide ion is cyanide ion. Formation of cyanide. How cyanide is formed? It is nothing but purely covalent because both are non-metals. Carbon and nitrogen are non-metals, and potassium and cyanide ion will form finally potassium cyanide. So potassium cyanide is ionic as well as covalent. So answer is potassium cyanide. I hope it is clear. So which is forming potassium cyanide means potassium cyanide is covalent in nature. Sorry, cyanide, a formation of cyanide is covalent, and potassium and cyanide together they are combining to form, that is K plus and Cn minus, because cyanide is gaining electron from potassium, because potassium is one electron, one potassium contains one free electron. So due to this, what happens? Potassium loses its electron and forms K plus, whereas cyanide gains that electron and forms Cn minus. And on the whole, they combine together to form KCl. So this is called a bond formation, ionic bond. So formation of potassium cyanide is ionic, but formation of cyanide is covalent. Formation of only cyanide, if we take into consideration, formation of cyanide is covalent. So this is called the compound which contains both ionic and covalent bond is potassium cyanide. So for example, ionic compound means simply you can say metal and non-metal combination. So for ionic compounds, you can recollect this. For all ionic compounds, metal and non-metal combination, metal and non-metal combinations, metal and non-metal combination. So covalent compounds, non-metal. This already we discussed in the formation of ionic bond as well as covalent bond. Non-metal plus non-metal combination. So I hope it is clear now. We'll proceed to next question. Next question. The total number of electrons that takes part in forming the bond in nitrogen molecule is. So the total number of electrons that takes part in forming the bond in nitrogen molecule. So nitrogen molecule formation. Let us see formation of nitrogen molecule. These type of questions, simple questions they are asking, but still they are having some meaning. So nitrogen molecule, already we know, nitrogen combines with another nitrogen to form triple covalent bond. So this nitrogen shares 3 electrons, and this nitrogen shares 3 electrons each. So on the whole, they are sharing total how many? 6 electrons. So the total number of electrons that takes part in the formation of bond, that is in the forming of bond in the nitrogen, is simply you can say 6 electrons because it is formed by triple covalent bond. So single covalent bond, 2 electrons. Double covalent bond, 4 electrons, and triple covalent bond, 6 electrons. So 6 electrons is the answer. So answer is C option. I hope it is clear. You can just note down. We'll proceed to the next question. Question number 4. Element X is strongly electropositive and Y is strongly electronegative. So they are giving electropositive and electronegative. Both are univalent. Univalent means having only valency one. The compound formed would be compound formed here. They are asking compound, not the ion form. So simply X plus Y minus is correct. X minus Y minus is wrong. So XY is correct. So X mark Y is wrong. So simply they are given for understanding X changes to Y. This is called what? X changes to Y, which is wrong. X single bond Y is correct because a valency of X is 1 because it can lose 1 electron, and the valency of Y is Y 1 because it can gain 1 electron. So X is positive and Y is negative. But they are asking the compound formed between them. This is not the compound form. These two combine together to form XY. So answer is simply X single bond Y. So it is C option again. I hope it is clear. So this type of questions also they're asking. The same question they'll ask in this also. A, the element A, whose valency, which has three valence electrons in the valence shell, three valence electrons. For example, I'm giving one more question, three valence electrons, and element B has six valence electrons or five valence electrons, anything they'll ask. So valence electrons. The compound formed between element A and B is, what is the formula of the compound they'll ask. So simply you can say atomic number, valency of A is 3 because it has only three electrons in the valence shell. But coming to B, as it is having six valence electrons, we have to take 8 minus 6, so it is equal to 2. So we can say this is A3 B2, and by crisscross method it is nothing but A2 B3. So answer is A2 B3, not A3 B2 also. So like this question they'll ask, even they'll ask the type of bond between them also they can ask. So anything they can ask. So I hope it is clear. So next question. So in this question, the previous question answer is C. So which of the following compounds is covalent? Which of the following compounds is covalent? Covalent they are asking. So simple direct question it is. Which of the following compound is covalent? So for first option we have hydrogen. Second option we have calcium oxide. Third option we have potassium chloride, and fourth option we have sodium sulfate. Clearly we can say hydrogen. There is nothing, no need to change because simply hydrogen is covalent bond because it is found by sharing of electrons. So hydrogen molecule is found by sharing of electrons between two hydrogen atoms. So which is called nothing but covalent compound. So remaining calcium oxide is ionic, potassium chloride is ionic, sodium sulfate is also ionic. This is a very simple question. So it has come like that. So X single bond Y before the answer, and now it is hydrogen. I hope it is clear. Next. Question number 6. If a molecule MX3 has zero dipole moment, now dipole moment, what is dipole moment? We'll discuss. So if a molecule MX3 has zero dipole moment, the sigma bonding orbitals used by M, atomic number less than 21 are. So if a molecule MX3 has dipole, this is very typical question. So if a molecule MX3 has dipole moment, then so which of the sigma bonding orbitals used by atomic number M? So M is nothing but a metal less than 21. Less than 21 means mostly you can take up to calcium or pure P, sp hybridized, sp2 hybridized, sp3 hybridized. So which is the right answer we have to check. So already we know dipole moment is a vector quantity. First of all, dipole moment is a vector quantity. Since dipole moment is a vector quantity, because dipole moment is nothing but denoted by mu. So mu is nothing but what? So dipole moment is denoted by the letter mu. It's directional because it is a vector quantity. And in trigonal plane, so MX3 type, they're asking MX3 has zero dipole moment. Let us say zero dipole moment means BCl3, for example. So BCl3 has zero dipole moments. And in that, the planar geometry, since it has trigonal planar geometry, what is it called? It is called trigonal because MX3 type means trigonal planar geometry. So if a molecule MX3 has zero dipole moment, the sigma bonding orbitals used by M, atomic number less than 21, are only P, sp, sp2, and sp3. So answer is sp2 because the vector sum of two bond moments is equal and opposite to the dipole moment of the third bond. So it is nothing but what? If it is sp2 mx3 type means simply I say, let us say M, X means halogens already we know. So this side one side X, one side X, one side X. And here dipole moment existing between M2X because X is more electronegative. M2X, simple understanding, you can try to understand this. And here also M2X. So since dipole moment is going three sides, so electrons are going from M to X and all are sigma bonds. The sigma bonding orbitals used by M are. So M will be definitely S orbital and X will be definitely P orbital. So since M is S orbital and X will be P orbital, so they will use sp2 hybridize. And why we can say only sp2 hybridize? Because for MX3 the shape is trigonal planar geometry. For mx3 molecule, the shape is what? Trigonal planar geometry. And the vector sum of two bond moments is equal and opposite to the dipole moment of the third bond. So the vector sum of two bond moments, these are the two bond moments, the vector sum is equal to third one. So they cancel out each other. So due to which what happens? So the reason, exact reason I'm writing here, the vector sum of, we also can note down the reason, the vector sum of two bond moments, that is up and down. You can see this, these are the two bond moments, is equal to, is equal and opposite to, is equal and opposite to third bond. So that is nothing but, so these two are equal and it is equal to and opposite to third one. This is the one. So these will cancel out each other. So answer is mx3 type having zero dipole. So that's why the net dipole moment is zero, because this rule is there. The vector sum of two bond moments is equal and opposite to third bond. So these two are equal and opposite to third bond. So this will be, suppose if I say this is positive value and this will be negative, so both cancel out each other. On the whole, the net dipole moment is equal to zero. So as the net dipole moment is equal to zero, we can say the answer is third option. So this type of questions are most important, and this rule is also important. The vector sum of two bond moments is equal and opposite to third bond. This you'll get in mathematics, since NEET students are also there. So that's why I have written this. Mathematical students can easily understand that rule. But NEET students, just you think this oppositely movement is not equal, is equal to third one. So whenever you get mx3 type, you have the bonds like this. So example, you can take bx3, anything. So I hope it is clear. Next question. The ion that is isoelectronic with CO is, the ion that is isoelectronic with CO. So just getting it down. The ion that is isoelectronic with CO is, CO is what? Carbon monoxide. Carbon monoxide means it contains carbon atomic number. Let us take atomic number of carbon. So carbon atomic number 7 and oxygen atomic number 8. So total how many? Total 7 plus 8. So it has 15 electrons. CO is having how many electrons? 15 electrons. Let us take into consideration cyanide ion. Cyanide means isoelectron, means which contains, isoelectron means same number of electrons. Same number of electrons. So those are called isoelectronic. So let us see cyanide ion. Carbon is, sorry, carbon atomic number is 6 and oxygen is 8. So it is total, it is 14. So 14 electrons only have to see. Very, so the atomic number of carbon is 6 and oxygen is 8. So 14 electrons, same number of electrons. So which will contain 14 electrons, we'll see. So carbon atomic number is 6, nitrogen is 7, 6 plus 7, 13. And one more is there, minus is there, so plus 1. So 13 plus 1, total it is 14. So answer is first option, no need to verify any other one. Because O2 plus means 16, minus 1, 15. O2 minus means 16 plus 1, 17. Because oxygen O2 means like this, we are tried O2 plus, they have given like this here for the question problem. So O2 plus means how many? Oxygen, together two oxygen atoms means 16 electrons. 16 minus 1 plus means minus 1, it is 15. So which is not isoelectronic. So answer first option directly. Is it clear? So here I made a mistake, that is carbon is equal to 6. I have to consider. Somehow I got it as 7. It is wrong. So atomic number of carbon is 6 and oxygen is 8. So I hope it is clear. I'm clearing the lines. So next question. Next question. So answer is cyanide ion. First option. Question number 8. On hybridization of 1s and 1p orbital, we get two mutually perpendicular orbitals, two orbitals at 180 degrees, four orbitals directed tetrahedrally, three orbitals in a plane. So here the question is what? Again I'm repeating. On hybridization of 1s and 1p orbital, on hybridization of 1s and 1p orbital, we'll get two sp hybrid orbitals on the plane or perpendicular to plane. So first option is what? Two mutually perpendicular orbitals, two orbitals at 180 degrees, four orbitals directed tetrahedrally, three orbitals in a plane. Simple it is. because one s and one p orbital overlapping to form two new equivalent orbitals. So if you see the nodes in sp hybridization, so when one s and one p overlaps with each other, they combine together to form two new equivalent orbitals. Two new equivalent orbitals, which is having sp, and these orbitals lie in the same plane. So usually they have s 180 degrees. Two orbitals at 180 degrees. Two mutually perpendicular orbitals, no. Four orbitals directly tetrahedral, no. Three orbitals in a plane, no. Only two new equivalent orbitals, and these two orbitals are at 180 degrees because we can take the shape of linear shape, because all sp hybridized, they'll undergo what type of shape? Linear shape. Linear shape is straight line. For example, BeCl2, BeCl and Cl. So the s orbital of beryllium combines with p orbital of sp hybridization. So it forms, beryllium undergoes sp hybridization to form BeCl2. BeCl2, this is Cl, this is also Cl. So the formula of the compound is BeCl2. So I hope it is clear. So answer is two orbitals at 180 degrees. Very, very simple question. I hope it is clear. We'll proceed to next question. Next question. The molecule having one unpaired electron is, so number of electrons, number of unpaired electrons also we have to consider. So the molecule having one unpaired electron is, question number 11 now. So the molecule having one unpaired electron, straight away we can see CO, NO, first letter C consideration NO. So they are given so many four options, NO, CO, CN minus O2. So let us take into consideration one unpaired electron. So for example, nitrogen is having how many electrons in the valence shell? 1, 2, 3, 4, 5 electrons in the valence shell. And oxygen, it combines with oxygen, and oxygen can donate only 2 electrons. So can donate only 2 electrons. So formation of nitric oxide. So N triple bond O, actually you should take it as N triple bond O, because nitric oxide means the formation is N triple bond O. I'm clearing it again here. So it forms N triple bond O or NO. So in NO there are 7 plus 8, 15 electrons. Definitely it has unpaired electrons. Simple it is. Even you can take, if you don't know this also, you can remember like this, CNO. So NO, nitrogen is atomic number is 7 and oxygen atomic number is 8. So 7 plus 8, 15 electrons. So with 15 electrons they are combined together. So definitely it has one unpaired electron, because 15 means it's even odd number, so definitely it should have one unpaired. Coming to CO, if you take into consideration, C carbon is 6 and oxygen is 8, so 6 plus 8, 14, no unpaired. Cn minus, carbon is 6, nitrogen is 7, one more minus, 6 plus 7, 13, 13 minus, one more minus is there, so 14. And O2 it is 16. O2 is nothing but already 8 electrons plus 8, 8 plus 8, it is equal to 16. So only odd number. So we can search in this unpaired electron means we have to search for odd number electron. What number? Odd number electron. So I hope it is clear. So you can make a note of it. So even if you don't know N triple bond O also, you can take. So answer is A. So this is the answer. So answer is A. Now we'll proceed to next question. The bond between two identical non-metal atoms has a pair of electrons. So the question is, the bond between two identical non-metal atoms, identical non-metal, here the word is identical, like chlorine, bromine, iodine, fluorine. So carbon, any identical non-metal, nitrogen, oxygen, all will come under. Identical means same. Here very important, the word identical means what? Here word identical means same type of atom, same atoms, or you can say similar atoms, like oxygen, fluorine, chlorine, bromine, nitrogen, etc. So they are asking about these molecules. Unequally shared between the two, transferred fully from one atom to another atom with identical spins, equally shared between them. So right answer is equally shared between them or identical spins, anything we can say. So the question again I'm repeating here. The bond between two identical atoms, question number. So this is 10. The bond between two identical atoms has a pair of electrons equally shared between them. They form a covalent bond which is totally non-polar because of similar electronegativity. So they share equal. They share equally between them. So answer is what? Equally shared between them. We cannot say about identical spins transferred fully from one atom to another atom is wrong anyway, because transfer means it is not covalent bond, it is ionic bond. And unequally shared between the atom, it can be happen only in polar covalent, but polar it is not for between identical, it is different, because polar is not identical. Because example HCl is not identical atoms, non-metals. Hydrogen is one more and chlorine is one. So HCl is polar, you can say, but it is unequally shared. But the thing is, here they have mentioned identical. Identical means only we have to see all these things like oxygen, fluorine, chlorine, bromine, etc. So answer is equally shared between them, because if you see oxygen molecule formation, one oxygen shares two electrons, another oxygen also shares two electrons, and on the whole they are getting 8 electrons each. Fluorine, chlorine, bromine, nitrogen. Anyway, if you see all the things, you will get the same thing. I hope it is clear. So this question is simple and it's more confusing also. So in chemical bonding, we are going to expect this type of questions only. Next question. Which of the following compound has zero dipole moment? Very, very important. Zero dipole moment. They are asking the question. Which of the following compounds has zero dipole moment? So if you see here, 1 comma 1 dichloroethylene, 1 comma 1 dichloroethylene. Let us take, I'll write the structures of all, then only you can understand easily. So zero dipole moment they're asking. 1 comma 1 dichloroethylene. Dichloro means two chlorines, ethylene means C2H4. So C double bond C, anyway it will be there, and one hydrogen, and there 1 comma 1, sorry, 1 comma 1 dichloroethylene. 1 comma 1 means for first carbon only hydrogen is removed. So we can take for first carbon hydrogen removed and replaced with chlorines. So we can say Cl, Cl, 1 comma 1 dichloro, and here hydrogen will be there. So this is called 1 comma 1 dichloroethene. So dipole moment existing between this carbon to chlorine and this carbon to chlorine. So these two are having dipole moment. So it has no dipole because this is going this direction, this is going this direction. So perpendicular to each other. So perpendicular means there is magnetic moment exists, mu exists. For first option. Second option, we know cis 1 comma 2 dichloroethylene. 1 comma 2 dichloroethylene means same C double bond C, and here hydrogen and hydrogen, and they're asking cis means on the same side, chlorines will be there. Trans means opposite sides you will get. So for this also dipole moment exists because there are different directions. Dipole moment exists. So I'm writing the symbol of dipole moment will be like this. So this is also not uh, zero dipole moment. No. Now coming to trans, it is the answer. Why? Because between cis and trans is having dipole moment zero dipole moment because of, for example, trans. How will you write for the same molecule? C double bond C, chlorine this side and chlorine this side, and hydrogen this side and hydrogen this side. So for dipole moment existing between this carbon and this chlorine and this carbon and this chlorine. As these two are equal and opposite, they cancel out each other. So net dipole moment mu is equal to 0. So what is the statement here? In trans 1 comma 2 dichloroethylene, net dipole moment is 0 because the two dipole moment vectors are equal and opposite. So these two dipole moment vectors are two dipole moment vectors are equal and opposite. Two dipole moment vectors are equal and opposite. Hence, they cancel out each other. So net dipole moment is 0. Net dipole moment is what? 0. They cancel above each other, and hence net dipole moment is 0. So dipole moment means nothing but the migration of one electron from less electronegative atom to more electronegative atom in a molecule. The migration of electrons from less electronegative atom to more electronegative atom in a molecule. So for example here, carbon, from carbon it is going towards chlorine because chlorine is highly electronegative. So it will pull the electron towards itself. So that is nothing but what? The migration of the attraction of electrons from less electronegative atom to more electronegative atom is nothing but dipole moment. It is denoted by letter mu. Mu is equal to E into D, where E is called charge and D is called distance between them. and it is measured by device. So already we discussed this topic in lectures. So I hope it is clear. So for in between cis and trans is having dipole moment, net dipole moment is 0, whereas cis is having dipole moment 6. For cis isomer, dipole moment exists because these are not opposite to each other. Whereas for trans, the two dipole moments vectors are equal and opposite. That's why the net dipole moment is 0. I hope it is clear. Please note down the reasoning also in your classwork so that it will be easy, because whenever we conduct exam also, you can understand easily and you can write the same reason. Next question. The molecule that has a linear structure, simple linear structure means we have CO2, NO2, SO2, SaO2. So for example, CO2, if we take into consideration, each and everything we can take into consideration, not only CO2. So let us take solvation. So linear molecule means either you can identify this type of questions, either you have to remember directly shape, or else you can take hybridization topic. If you identify hybridization, or if you identify hybridization simply, if you identify hybridization directly, you can say linear, because sp hybridization linear, sp2 trigonal planar, sp2 trigonal planar, and sp3 tetrahedral, and so on. Already we know the shapes based on hybridization. So let us find out the hybridization of carbon. So carbon dioxide, so carbon dioxide hydrogen hybridization H is equal to half into p plus m, or you can take even n factors also, number of bonds, number of lone pairs and bond pairs. Simply you can take that also. So I'm taking hydrogen, valence electrons of carbon atom, half into V plus M minus C plus A. So even you can use this, or you can write H is equal to total number of bond pairs plus lone pairs, bond pairs plus lone pairs. For example, let us take into consideration both sides. I'll show it clearly. So if you take H is equal to, so for this, if you write here H is equal to, you can have any of these two methods. So for, let us see first one. So for carbon, how many valence? 1 by 2 into valence electrons is how many? 4. And monovalent atoms, because oxygen is divalent. Oxygen is what? Divalent. So we cannot write it is monovalent. So half into 4 plus 0. Just making it clear, one second. Half into 4 plus is there, plus monovalent 0 minus cations 0, anions 0. So 4 into 4, half into 4, it is equal to 2. So H is equal to 2. Now similarly, for example, for this, if we take into consideration carbon, carbon atomic number 4, 1, 2, 3, 4, 4 electrons in the valence shell, and with 2 oxygens, it will share 2 electrons. So this oxygen, it will share 2 electrons. This oxygen, it will share 2 electrons. Simply you can say, so total how many electrons it is sharing? 8 electrons. How many electrons? Total, sorry, it is sharing 8 electrons, but here 1 bond pair and here 2 bond pairs. So total bond pairs is equal to 2 bond pairs, and there is no lone pair, 0. Even though it shares 2 electrons also, we consider it as 1 bond pair because it is forming 1 double bond. So since C double bond O, C double bond O, we can call it as 1 bond pair and 1 bond pair. So n factor is 2. So 2 and 2 in both the cases. And n factor is 2 means sp, because n is equal to sp. N is equal to 3, sp3. N is equal to 4, that is h value. So answer is CO2. So you can check this type of questions. If you don't remember the shapes of molecules, important molecules, if you no need to remember also, just by logically also you can do. So you can use either this method, half into V plus M minus C plus, especially this method is useful for ions, because if you take SO4 2 minus, as we discussed in the class, SO4 2 minus, like that, you'll use this method directly, you can get the answer. Whereas this method is you can use for all types, even ions as non-ions also, total, that is neutral molecules also, and ions also. So if H value is equal to 2, it is sp. 3 is sp means linear shape. If H value is equal to 3, it is sp2 and trigonal linear shape. And if they have lone pairs, then we can say the shape is distorted and hybridization is different. So anyway, you can use Vesper theory as well as hybridization for solving this type of questions. Either Vesper theory, you can use either Vesper theory or hybridization for solving this type of questions. So I hope it is clear. So both these topics are most important, Vespathy as well as hybridization. So I hope it is clear. Now next question we'll see before into the next question. Next question. The C single bond Cl. So carbon one side is Cl, another side also is Cl. Anglin 1 comma 1 2 comma 2 tetrachloroethene and tetrachloromethane, tetrachloromethane. So both molecules they are given respectively will be about. So again if it in the question, the Cl carbon atoms. So they are asking in both. So let us take for this type of question. So in one the first carbon is what? 1 comma 1 2 comma 2 tetrachloroethene and second one is tetrachloromethane. So let us take into consideration now. First, we'll draw the structure for this. First one, what is that? 1 comma 1, 2 comma 2, tetrachloroethene. Ethene means C double bond C. And 1 comma 1, 2 comma 2. So all the hydrogens are removed and replaced with chlorines. I'm writing only for first compound. This is now first compound. And this is 1 comma 1, 2 comma 2, tetrachloroethene. Tetrachlor, total four chlorines. C2, actually ethene means C2H4. So C2H4 means 2 carbons and 4 hydrogens. C2H4. And this is called ethene 1 comma 1 2 comma 2 tetrachloroethene. So in this the bond angles is 120 degrees. The bonding because alkenes, these are nothing but alkenes. Alkenes the bond angle is what? 120 degrees. Similarly, if you take 1 comma 1 comma 1 2 comma 2 only the second one is what? Tetrachloromethane. Only second one is tetrachloromethane means simply so for all hydrogens are removed and replaced with chlorines. And this is nothing but tetrahedral shape, and for tetrahedral shape the bond angle is 109.5 degrees. So I hope this is alkane, this is alkene. Alkenes have 120 degrees and alkanes have 110.5 and alkynes have 180 degrees. Alkynes, what is the bond angles? Because alkynes usually the shape is linear, so alkynes is 180 degrees. So bond angles. So now the bond angle is 120, 109.5 respectively. Respectively means first one should be 120, second one should be 105. So answer is A. I hope this is clear. Next question. The molecule which has a pyramidal shape. Pyramidal shape means like you take, like in the case of ammonia. Ammonia is nothing but what? Pyramidal shape. So the molecule which has pyramidal shape, they are asking the question. The molecule which has pyramidal shape. So first one PCl3 they are given. So simple you can say like ammonia we have PCl3. So how will you say here? What is a pyramidal shape? Pyramidal shape means what is the first basic idea? They should undergo sp3 with one lone pair of electrons. So pyramidal shape means which type of molecules will undergo pyramidal shape? First I write that condition. So pyramidal shape means first pyramidal shape means it should undergo sp3 hybridization with one lone pair of electrons like ammonia. So one lone pair of electrons. Let us take now PCl3. PCl3 means if we take into consideration PCl3, so phosphorus trichloride. Phosphorus is having how many valence electrons? 5 valence electrons. 1, 2, 3, 4, and 5. And with each chlorine, it will take one electron, one electron, one electron. And it has how many three bond pairs? It has how many bond pairs? 3 bond pairs plus one lone pair. Nothing but what? So sp3 hybridization with 3 bond pairs and one lone pair is nothing but what? Pyramidal shape like ammonia. So answer is PCl3 straight away. No need to see others also. So pyramidal shape, the molecule which has pyramidal shape is PCl3 because it has 3 bond pairs and one lone pair. It undergoes sp3 hybridization and these are the 3 bond pairs and one lone pair. So this is called one lone pair. I hope it is clear. So this is question number 14. So all these models are very important. Why we are discussing all these models? Because these are all nothing but previous competitive exams. So what type of questions you are going to get still now, on which areas you are going to get more questions, so that we can work out more questions on that area. So that's why this topic is very important. Next, the molecule which has zero dipole moment. Again, this question has come, zero dipole moment. So zero dipole moment, the molecule which has zero dipole moment. So again, you can see the type of molecule which contains either that zero dipole moment means only two rules we have. One is sum of two. So CH2Cl2, if we take into consideration, let us see CH2Cl2. CH, H, Cl and Cl. You can take like this. So CH2Cl2 dipole existing between this carbon and chlorine. So, and second one BF3. Just BF3 you can understand easily. Boron, it contains how many valence electrons? 3. One with the fluorine, another with the fluorine, another fluorine. That is bigger one. So dipole moment existing between, because fluorine is more electronegative. So fluorine is more electronegative. Dipole existing between boron and fluorine, boron and fluorine, and third one is also boron and fluorine. So these two are equal and opposite, and it is equal to these two, the sum of two vectors. Same rule again. Sum of two vectors is equal to the third vector which is opposite in direction. Third one equal to third one which is opposite. Is exactly mutually perpendicular. You can see these two are opposite to this because this is going this direction, this direction, and these two are opposite, exactly opposite to this one. So which is opposite in nature. So they cancel out each other. They cancel out each other. So that's why the answer is BF3. So the molecule which has zero dipole moment is BF3. So NF3 will not get like this because nitrogen is going from nitrogen to fluorine as nitrogen. In case of NF3, even if you get it out of here, they have given one more interesting option, NF3. Why NF3 is not the right answer? Because nitrogen is having 5 electrons in the valence shell. How many electrons? 5 electrons. And with each fluorine, they'll combine. And it has one lone pair also. It has how many? One lone pair. So lone pair will make the difference. So due to which what happens, the dipole moment is zero. But here no lone pairs. No lone pairs. So suddenly you might get the answer. Even students, everyone student will get out. If BF3 is the answer, then why not NF3? So anyway, other two are different. But BF3 and NF3, they are very close. And even if you see NF3 and BF3, but BF3 has no lone pairs, NF3 has one lone pair. This makes a difference, due to which what happens, this law cannot be applied for that. So I hope it is clear. Very, very important question. So this type of questions we are getting. So that rule is very, very important in dipole moment. Next, the type of hybrid orbitals used by chlorine atom in ClO2 minus is the type of hybridization, the type of hybrid orbitals in chlorine atom. So very, very important question this is. So the type of hybrid orbitals in chlorine atom used by chlorine atom in ClO2 minus is ClO2 minus sp3 sp2 sp. Simple, directly you can find out the using the formula. As this is ionic form, you can use the formula H is equal to half into B plus M minus C plus A. Use this formula directly. So now you can see here half into valence electrons of chlorine atom 7. For chlorine monovalent atom is oxygen is not monovalent, so you can say plus 0 since oxygen is not monovalent, and minus cations. There is no positive charge over here, minus 0, plus anions 1 is there because minus is there, so plus 1. So it is nothing but what? Half into 7 plus 1, 8 by 2. 8 by 2 is 4. 4 means sp3. Straight away we can write. So answer is sp3. I hope it is clear. The type of hybrid orbitals used by the chlorine atom in ClO2 minus is simply they are asking what is the hybridization involved in ClO2 minus. So as I told you, for ionic forms, we can use this formula easily. For neutral molecules, we can use the formula number of lone pairs plus bond pairs. for H. If H is equal to 2, sp. If H is equal to 3, sp2. If H is equal to 4, sp3 or dsp2. dsp2 only if transition metal is involved, like platinum. So if transition metal is involved, then only we consider d orbital. Because for chlorine we have only p orbital, we do not have d orbital. It has empty d orbital, but p orbital only will be there. So H is equal to 4. H is equal to 5, sp3d, sp3d, sorry. H is equal to 5, sp3d. So this all we have discussed in the class. So I hope it is clear. So please copy down this answer. Very, very important. Simple question actually. So how to find hybridization for ions and neutral molecules. For neutral molecules, you can use this formula. For ions also you can use this formula, but you have to draw the diagram for chlorine and oxygen where it is gaining or out, right? So it's very difficult to understand for you students anyway. So that's why it's easy because it will take more time. So this will be easy for all neutral as well as ions. So straight away you can take, because you should know the valence electron. What is V? Number of valence electrons on the central atom. What is M? Number of monovalent atoms attached to the central atom. So what is the central atom here? Chlorine. And C, number of cations. There is no cation here because no plus charge is given. And A, number of anions. How many anions? -1. Suppose if they have given -2, you have to keep here 2. For anions, only the number you have to take, but plus sign should be there as it is. So answer is sp3 hybridization. So here it is called sp3 hybridization. sp3. So answer is first option. I hope it is clear. Next question. The maximum possible number of hydrogen bonds in water molecule can form. Very, very important question. What is the question here? The maximum possible number of water molecules in hydrogen atom in water molecules. So how many water molecules it can form? The maximum number of hydrogen bonds a water molecule can form. Water molecule can form. What is hydrogen bonding? The bond formed between hydrogen and electronegative atom. So oxygen is having hydrogen and hydrogen like this. Okay, so this is called oxygen and hydrogen, and this hydrogen is in attraction with one more oxygen of second molecule, and this hydrogen is again it is attraction with second oxygen molecule, one more water molecule, sorry. So like this is goes on. So maximum it can go, the maximum possible number of hydrogen bonds a water molecule can form. Possible hydrogen bonds a water molecule, since they are asking about only single water molecule. So again repeating, the maximum possible water molecules are the maximum possible number of water molecules. Again I'm telling the answer. So it is 1, option 1, A is 2 and B is, so just giving you the answer 4. How many it can form maximum? Like this it is 4. So answer is how much? 4. So the maximum the possible number of water bonds to a water molecule can form 4, because it can form sp3 hybridization. sp3 and hybridization is equal to 4. So 1s and 3p orbitals. So maximum possible water molecule it can form. This will can form maximum 4. So answer is very 4. 4. This is very, very important question. So the maximum possible number of hydrogen. What is hydrogen bond? The bond formed between hydrogen of one molecule and electronegative atom of another molecule. It was represented by dotted lines. The bond formed between hydrogen of one molecule and electronegative atom of other molecule is called as hydrogen bonding. This type of bonding is called what? This is called inter, because it is formed between two molecules, not one molecule. So intermolecular hydrogen bonding. What do you call it as? Intermolecular hydrogen bonding. And answer for this is 4. Very, very important question. Please note down. This question is most important. So many times it has come. And answer is blindly. You can remember this answer 4, because it is undergoing sp3 hybridization. I hope it is clear. Next question. Which of the following molecules is planar? Planar means trigonal planar. Trigonal planar means what? What type of hybridization they should undergo? Simple. Directly, if you don't know the shapes of molecules, you can go for hybridization. So if a molecule has undergoing sp2 hybridization, it is nothing but planar. That is nothing but trigonal planar. Trigonal planar and planar both are same. So which is undergoing sp3 hybridization without lone pairs. Without lone pairs. So NF3, if we take NF3 hybridization in NF3, so here you can say H is equal to half into valence electrons of nitrogen 5 and central atom, and monovalent atom, since fluid is monovalent, we'll say it is 3. So minus 0 plus 0. So 5 plus 3, 8. 8 by 2 is 4. 4 means sp3, not trigonal planar. Second option NCl3. NCl3 also same. pH3 phosphine and BF3. Here BF3 is answer because phosphorus is also having 5 electrons in the valence shell, 3. 5 plus 3, 8 by 2. And nitrogen again 5, and here 3 chlorines 3. Because all are mono. Fluorine, chlorine, and hydrogen are monovalent. Even here also monovalent. But boron has how many valence electrons? Boron has how many valence electrons? Only 3 valence electrons. How many valence electrons? 3. And these three are so H is equal to 5 BF3 molecule. If we take into consideration BF3, boron has how many valence electrons? 3 valence electrons. 3 plus number of monovalent. Fluorine is monovalent, so it is adding 3 minus 0 plus 0 because there is no cation, no anion. So here total half 1 by 2 plus 6, 1 by 6 by 2. 6 by 2 is 3. 3 means sp2. So answer is basic idea sp2. So answer is D. I hope it is clear. So for which of the following molecule is planar means you have to take trigonal planar. Trigonal planar will be only for sp2 hybridization, and that the answer is BF3. So this is sp2 hybridization. It is clear now. Next question. The number and types of bond between two carbon atoms in CaC2 is very, very important. This type of questions are important. Sigma bond, pi bond. How to calculate sigma bond and pi bond? Just I write here clearly. So you can understand easily. Again, we're recapping it. For single covalent bond, we have 1 sigma bond. For double covalent bond, we have 1 sigma, 1 pi. This already I have explained in the lectures. For triple covalent bond, we have 1 sigma, 2 pi. And in calcium carbide, the carbon atom is undergoing CaC2. CaC2 means C triple bond C. These carbons are undergoing calcium carbide, carbons are undergoing C triple bond C, will because the hydrolysis of calcium carbide leads to the formation of, so in calcium carbide, carbon and carbon are linked by triple covalent bond. And if you take into consideration this equation, if you take CaC2 on hydrolysis forms C2H2, very, very important. This C2H2 means carbon and carbon are going by triple covalent bonds. Since triple covalent bond means it contains 1 sigma and 2 pi bond. So answer is 1 sigma and 2 pi bond. So second option. So 1 sigma and 2 pi bonds. This is the answer. So I hope it is clear. So for this type of questions, for to solve this type of questions, definitely you need to know the structure. If you know the structure of the compound, easily you can identify number of sigma bonds and pi bonds. Structure of the compound is important. So you know the structure of the compound. So if you know the structure of compound, easily can find sigma bonds. How to find sigma bonds? If there is only single covalent bond between them, 1 sigma. Double colon, 1 sigma, 1 pi. Triple colon, 1 sigma, 2 pi. So these type of questions are most important. I hope it is clear. Next question. And the following compounds in the order of increasing in the order of increasing dipole moment. First toluene, M dichlorobenzene, O dichlorobenzene, P dichlorobenzene. Very, very important. First, let us see the structures, because for this type questions, we need to know the structure of this, because first we'll say toluene. Toluene means TOULENE. That is nothing but methyl benzene. On benzene ring, we have, just trying it, maximum trying my best. So this is called toluene. And in the second one is got O dichlorobenzene. O dichlorobenzene means at ortho position. First M dichlorobenzene. So this is first compound toluene. Second compound is M dichlorobenzene. M dichlorobenzene means here on the benzene ring, One chlorine is at first position, and second position we have M dichlorobenzene. Third one O dichlorobenzene. O dichlorobenzene means this is first position. Sorry, here I'm rubbing it clearly. So this for this answer you should know because this is come for competitive exam. And even when we are discussing about dipole movements, also we discuss this type of examples also. So you can refer that lecture on notes. So this is M dichlorobenzene. Next, O dichlorobenzene. O dichlorobenzene means this is first option. Sorry, second option, first option, third option. No, third option I'm drawing for this also. Is called what? Chlorine will be on the top, and O means this is the ortho position. So O dichlorobenzene, two chlorines, benzene, and third one P dichlorobenzene, P. This is third one, and fourth one what we have P dichlorobenzene. And for in the dipole moments examples when I explain the class, we already know O is greater than M is greater than P. Dipole moment follows the order. O is greater than M is greater than P. The dipole moment order for the same compounds. O is greater than P is greater than, so M is greater than P. So in between, and this toluene CH3, there is no dipole moment existing in this because it should have least one because why? Because CH3 is positive group. CH3 is what? Positive electron, not electron withdrawing group. It is electron releasing group. ERG. What do you call it as? ERG. Whereas dipole and it is less electronegative. And this is electron withdrawing group. EWG. EWG means electron withdrawing group. This will be knowing in organic chemistry. By the time we start organic chemistry, you can understand that. So, so this is 1, 2, 3, 4. So the order for this is one. So in between 2, 3, and 4, the order is compulsory. 3 greater than 2 greater than 4. So 3 greater than 2 greater than 4 greater than 1. So least is last, first one. So first one should be least means increasing order. So increasing order they have given, not decreasing order. You have written decreasing order. So reverse of this 1 less than 4 less than 2 less than 3. Answer is 1 less than 4, 1 less than 2 less than 3. So 1 less than 4 less than 2 less than 3. Answer is first option. So I hope it is clear. So dipole moment in the session also we discussed about this. So dipole moment existing. So 1 less than 4 less than 2 less than 3. Next question. The cyanide ions Cn minus and N2 are isoelectronic, but in contrast to cyanide minus and N2 is chemically inert because of cyanide ion is a radical and N2 are isoelectronic. Because they are both are isoelectronic means what? Which contains same number of electrons. So how many electrons cyanide ion is having? Nitrogen atom, nitrogen molecule 14 electrons. So cyanide ion also 14 electrons. So they are isoelectronic. But in contrast, cyanide ion N2 is chemically inert because of low bond energy, absence of bond polarity, unsymmetrical electron distribution, presence of more number of electrons in bonding orbitals. Yes, this is the answer. In bonding orbitals, more is present in nitrogen. So presence of more number of electrons in bonding orbitals. So that's why, because cyanide ion carbon C triple bond N, and here one more minus is there. So nitrogen getting only 4 electrons after sharing, but presence of more number of electrons I have. So next we have next question. So the presence of, so they're asking in chemical inert, why nitrogen is chemical inert? Because of low bond energy? No, because N triple bond N, nitrogen exists as N triple bond N. It has highest bond energy, absence of bond polarity. So what is bond polarity? Bond polarity is nothing but polar covalent bond, and here there is no absence of bond polarity. And next we have, yes, here absence of bond polarity. In nitrogen molecule, there is no polarity between nitrogen because equal sharing electrons there. So answer is B, not D. Presence of more number of electron bonds is present in cyanide because it is having more number of electrons. So absence of bond polarity is the right answer. The cyanide ions and nitrogen are isoelectronic, but in contrast to cyanide ion, nitrogen is chemical inert because of absence of bond polarity. As there is no bond polarity. Bond polarity means attraction of electrons from one atom to another atom. So that is not happening here, but in cyanide it is there because nitrogen is more electronegative. So it will pull the electrons from carbon to nitrogen. Carbon is less electronegative, but here it is of similar like atoms. So there is no coming up this point. So absence of bond polarity is the right answer. And presence of more number of electrons being bonding orbitals is there for cyanide, not for nitrogen. But we are discussing about nitrogen is chemical inert because even though they are isoelectronic, but nitrogen is chemical inert when compared to cyanide because cyanide is more reactive and nitrogen is less reactive. They are asking because of absence of bond polarity. I hope it is clear. So next question. So all these type of questions are important. According to MOT, that is molecular orbital theory, O2 plus is paramagnetic and bond order is greater than. O2 plus is paramagnetic and bond order is greater than. This question is very important. So according to MOT, O2 plus, question number 22. So first question is what? O2 plus is paramagnetic and bond order is greater than O2. O2 plus bond order already you know. O2 bond order is 2, O2 plus is 2.5 and O2 plus is paramagnetic because it contains unpaired electrons and O2 is also unpaired electron. It contains unpaired electron. So O2 plus is paramagnetic and bond order is less than O2. O2 bond order is how much? The bond order of oxygen is 2. How to find bond order? Number of electrons in bonding minus number of electrons in anti-bonding, Nb minus Na by 2. So the oxygen bond order of oxygen is 2, already we know. And O2 plus means one electron is missing. One electron is missing means its bond order increases. O2 plus, for example, let us consider O2 plus bond order. O2 plus, how many electrons total? O2 plus is how many electrons? Total oxygen is 15. So O2 plus means 15 electrons. 15 electrons means that electrons should go from anti-bonding orbital. Sorry, anti-bonding orbital in case of oxygen. So here sigma 1 is 2. Let us write the molecular orbital sigma star 1 is 2, sigma 2 is 2, sigma star 2 is 2, sigma 2p z 2. In case of oxygen, I told you this will come first. Pi 2px is equal to pi 2py 2 and 2. So total how many letters already finished? 1, 4, 6, 2, 4, 6, 8, 10, 12, 14. One more electron. One more electron is pi star 2px 1 and pi star 2py 0 because 15 electrons already over. Now here bond order. Let us take into consideration bond order. So 1 is to sigma 1 is sigma 2 is sigma star like this. So total 10 minus number of bonding electrons is 2, 4, 6, 8, 10 minus anti-bonding 2. So how many here? 2, 4 plus 1, 5. So 10 minus 5 by 2 is equal to 2.5. Very, very important. It is equal to how much? 2.5. So greater than 2.5 and it is having one unpaired electron. So it is paramagnetic and greater than 2. Oxygen bond order is 2 already we know because oxygen is linked by double covalent bond O double bond O. So 2.5. So answer is first option straight away. I hope it is clear. Next question. The species having bond order different from that in CO is bond order different from that in CO. Let us find out the bond order for CO. Then answer yes, easily you can get it. So to find bond order, you have to use the same MOT configuration. So bond order you have to find. So CO bond order, you can write C triple bond O. So bond order is 3 because carbon and oxygen. Carbon is how much? 6 electrons and oxygen is 8 electrons. 6 plus 8, 14. 14 electrons. So 14 means it is similar to nitrogen. So bond order is 3. And NO minus, if you take into consideration, NO means how much? N is nitrogen is 7, oxygen is 8. 8 plus 7, 15, 15 minus 1, 14 minus 1 because plus is there. So 14. So NO minus. NO plus means anyway it will not come because NO plus means, so here NO minus we are taking, no minus means plus 1. So it is 15 electrons. Whereas NO plus, if we take nitrogen atomic number 7, Oxygen atomic number 8, 7 plus 8, 15. As plus is there here, so plus means one electron is removed, minus 1. So it is nothing but, so here it is plus 1 we have to add for this because minus is there here. So first option this is, second option this is A and this is B. So here it is 14 electrons. Simply if we take isoelectronic, it will be answer easy. Now cyanide minus also if we take into consideration. Third one, cyanide also. For cyanide, carbon atomic number is 6, nitrogen is 7, and minus is plus 1. So here this is also 14. Now nitrogen 16. Nitrogen is what? 16 electrons. But its bond order is 3 already we know. So answer the species having bond order different from that in CO is CO. Since cyanide is having 14, this is also 14, but this is 15. So answer is first option straight away. Different they are asking, not similar. But nitrogen, even though it contains 16 electrons, but the bond order is N triple bond N, already we know it by using MOT configuration. So answer is first option. I hope it is clear. So all these questions are most important. So now I'm writing summary of the topic. Summary of this chapter, what we have learned. Summary of chemical bonding. Writing it clear. Summary of the chapter. Topic 1, ionic bond and its compounds. Topic 2, covalent bond, properties of covalent compounds, etc. Types of covalent bonds, etc. Uses. Topic 3, we have dipole moment. Dipole moment, comma, bond parameters. That is bond length, bond energy, bond enthalpy, etc. Sorry, bond order. Next, we have very important Vesper theory and VBT. And finally, we have hybridization. And sixth, we have sixth topic is what? What we have in sixth topic? MOT. That is molecular orbital theory. So, to my knowledge, as we have done now, so many questions. So, since many years questions, we are getting questions from these three dipole moment. That is, you have to work out more questions on this when compared to all. And this is also slightly 2 star, and this is 1 star, and this is also 1 star. So maximum you have to work out on these three topics. What are those? Dipole moments, Vesper theory, bond parameters, VBT theories, hybridization. So I hope this is clear. This chapter is very, very important. So every objective, every year, at least for any competitive exam, they will give minimum 3 to 4 questions from this chapter. 3 to 4 questions, depending on the type of exam. Minimum is two, and maximum is 3 to 4 questions from this chapter you'll get. And that 3 to 4 questions you have to work out more on this only. Definitely they will give from these areas only mostly. So all these areas. So I hope this is very, very clear to you. So next time when we conduct exam, you are supposed to get very good marks in this. So proper use of PPT is very, very important. All the slides are very important. And if you make the slide as classwork, and if you do the answer and question, easily can understand. With this knowledge, you can do not only this, you can do any other material also. You can do general material also, any other material also. So I'm ending this session. I hope it is clear. So this topic is very, very important. Thank you all.